Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on November 18, 2025, just yesterday. It introduces the first comprehensive benchmark that stress tests large vision language models with misleading visual inputs, using 1,248 carefully annotated question-answering examples, and a new metric called MVI-Sensitivity to expose serious robustness gaps across 18 modern systems. The paper is titled MVI-Bench, a comprehensive benchmark for evaluating robustness to misleading visual inputs in LVLMs. And as we will see later, the implications for evaluating and hardening multimodal models are quite significant. Also, the authors shared a GitHub repo for MVI-Bench. Right now, it mainly offers a short overview of the benchmark and its goals, and it signals that the full dataset plus evaluation code are coming in the next week or two, so listeners can keep an eye on it for the actual tools. Figure 1 makes the core problem concrete by contrasting misleading text with misleading visuals. The top panel shows a normal dog photo, where only the written question is corrupted, so the model is nudged toward imagining a non-existent cat. The bottom panel keeps the question honest, but swaps in a tricky scene, where stools resemble mushrooms and lure the model into a wrong answer. Figure 2 shows how the benchmark turns misleading visuals into structured test cases. Each row illustrates one of the 6 categories, where a normal image and a subtly altered misleading image share the same multiple-choice question, but invite different answers. The left column images look straightforward, while the right column inject confusing cues such as reflections, occlusions, or visual illusions, so the model's choice reveals its visual robustness. Table 1 makes the claim very concrete. This benchmark is the only one that systematically spans all 6 misleading visual types, while also using paired normal and misleading images. The table contrasts 5 datasets by which tricks they cover, like visual resemblance, material confusion, or mirror reflection. It also records whether images are natural, synthetic, or manually edited, which matters because real photographs test robustness differently from stylized renderings. The bottom row shows that this new benchmark uniquely combines full category coverage, diverse image sources, and a strictly paired design. Table 2 spells out how individual models actually cope with each misleading visual type, and it shows that even the strongest systems still lose a lot of accuracy once images become deceptive. MVI sensitivity here means the relative drop from normal accuracy to misleading accuracy, so smaller values signal better robustness. The table separates open source and closed source models, which makes it clear that commercial systems tend to be sturdier, but still far from reliable. Several entries drop from roughly 90% on clean images to around 50% on misleading ones, especially for mirror reflections and occlusions. Alright, to wrap up, 2 takeaways stand out. Misleading visuals quietly break even top vision language systems, and robust evaluation really demands paired normal and deceptive images, plus a sensitivity metric like MVI sensitivity. The broader message is that safer multimodal I must start with stronger visual perception. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.